In 2025, they already reported that 50% of the code is AI generated, and then are pushing for 75%. I always like to look at the big players to see what they do, because on one side you see all of these crazy numbers like efficiency gains, or we automated our entire deployment layer with AI, like Spotify did, for example. But very seldom do you actually see how they do that, right? So they report all of these gains, but then how do you translate that to your own work? And that part is often missing. And for the big companies, I think, so if you look a little bit about how, what they publish and what they write, you can kind of see that they have like an approach that prioritizes reviewing now more, like it becomes more standardized, because they've identified that now that you can generate code very cheaply, the bottleneck is moving somewhere else. Now, some people, and this is another tangent, but some people would argue that writing code was never the bottleneck. Depends on kind of, how do you see software engineering. But truth of the matter is you generate 10x more code, so now you have more pressure on your reviewing, on your engineers, etc. And I think what the big companies are doing right now is they are combating that with policies on reviews. At Amazon, for example, there have been some instances where there were outages, revenue loss due to AI-generated code, and then they put in policies in place where they now require some parts of the code or some parts of the systems that they have to be reviewed by senior engineers before anything gets merged or deployed. So they are identifying that, in some cases, AI-generated code has to be scrutinized, stronger than in other cases. So you can see that. And at the same time, you see other companies who say, okay, we automated our entire PR review process. They're applying like these, how would you say? Well, I like to think about it as a little bit like there's a horizontal way of scaling AI engineering and a vertical one. Okay. The horizontal one is where you automate like processes you currently have, like a PR review. Like you can say any PR that is created, automatically reviewed with Copilot, for example. And that's what a lot of companies do. But then they don't really talk about how that improves the quality, right? So the automating part of the human pipeline that we have.
What's then the vertical axis?
The vertical axis is if you have a project and a small specialized team, you let them build their own tooling to make sure that the product ships and is developed in the way that they intend to. So they are more involved in building custom-built environments for their coding agents and for the team to deliver the software. Like they don't have a blueprint that applies to their product automatically. They refine it.
Yeah, and this is I see us stacking a lot of capabilities, right? We have the model on one hand, and then the agent kind of harness around the model specifically, and you're talking about an environment in which this agent harness operates. Yes. Or how should I view that?
Well, maybe we should just go back one step. So if we look at software engineering, I think it's a well-established process by now. Like if we think before the area of AI, software development lifecycle, everybody knows it. And part of, the review was done by humans, and it would work because code wasn't delivered faster than you could review it. That has changed now with AI. And so the question now becomes, well, how do you scale the reviewing process, right? Because now that is blocking your senior engineers. It burns them out. There are studies about that where, cognitive depth is growing, where people don't understand or their own code base because they just don't have the time to look at everything, or they don't even want to look at the AI-generated code, etc. And so the question is, how do you mitigate that? And one answer is, don't do any code reviews at all. Okay, but then the next question is, how do you do that? So I think one way to do it is to engineer the environment in which the agents operate with intention, so that you don't have to be the human in the loop to give the agent feedback on common things. And it starts with very simple things. So just, let's say, code formatting, automatic code formatter. We already had that. Or a security check. Lots of teams have integrated tools like SonarQube or something that gives you feedback that then a human would take and fix the code with, like with the feedback from those systems. Agents can do that automatically. So if you provide agents feedback on what they're doing wrong, and hopefully as close as possible to where the agent actually generates the code, which means on the developer's laptop, not necessarily in GitHub, after you made your commit or your PR, then you're suddenly in this world of where you're trying to engineer feedback to the agents in a way that helps the agents to run for a long time without human intervention. So that's what I mean by building these types of environments.
Yeah.
And I think it's very easy to get started with it. A lot of it will feel like, but we've been doing this before. But now you're giving the agent that feedback. You're not taking it as a human anymore, right? And some of the models are surprisingly good at self-correcting themselves once you pinpoint them what they did wrong, and let the environment give that feedback.
Yeah. Does the harness in this equation, does it matter which harness I use? GitHub Copilot, Cloud Code, Codex?
Oh yeah, absolutely. Well, in my experience, the harness matters more than the model.
Okay.
I mean, the harness is what provides the tools, what provides some type of prompting, provides the memory layer, and all of these things that then get submitted to the LLM to generate a response, for example, where the LLM wants to make a tool call, etc. And the harness provides then the capability to execute the tool call for the LLM. It matters immensely. I made an experiment in one of my projects where I tried to implement a tool based on specifications and tests. So I had a full suite of specifications, like specification-driven development, like many people like to do nowadays. The idea is that if you specify your product exactly enough, the AI will be able to implement it exactly according to specifications, which is unfortunately not true. But it's an attempt that I made and that failed. And then I thought, okay, what if I use the TDD idea and just generate me all of the behavioral tests up front, and then let that be the feedback to the agent who tries to follow my specifications. And depending on the harness that I used, it worked or it didn't work, even if I was using the top frontier model in both harnesses.
Okay. Which harness gave you the best results?
Well, that keeps changing all the time.
Yeah.
So at that time, it was Cloud Code.
Gotcha.
Now I would say that shifted to Codex for implementation work. But that's one of those things. That's like a moving target, which is also one of the reasons why you can't really stop experimenting. There's this tendency for software engineers to try to systemize things and make it a process. And okay, those are now the rules. I don't think that works. Things are still moving too quickly. Okay, maybe I should walk that back a little bit. It works at some level, but if you define in your policy we must only use Cloud Code, who knows what will happen when the next release comes out? Yeah, it might behave completely different because the models have different quote-unquote personalities. Like some are very good at instruction following, others are very good at filling in the gaps if you don't provide enough context as a human. So you need to be careful which model you use as well. Yeah,
I want to zoom in on kind of what you recommend for harnesses. But before we do, kind of following your trail of thought of spec-driven development and solving kind of the code review process in that way, you mentioned the TDD approach worked better than the spec-driven development approach with a model following instructions in that way?
Well, I would say, specs-driven was my first attempt.
Yeah.
And that didn't go well. It was a typical, okay, I create the perfect prompt, and then the model does something different I didn't intend. But when you give the feedback in addition to tell the model when it's off track, that worked for me in that particular instance. And I would say, those results might be transferable to other projects, but it really depends on the project, which again brings us back to the need to be willing to experiment what works.
Yeah, and this feedback, just so I understand, this is in an automated way, right? So you have specs, then you have execution, and the feedback is not you telling what it did wrong, but what does that feedback cycle look like?
Exactly, yeah. So when you're using like these CLI tools, you have the ability to define what is called, for example, a stop hook. So when the agent is done with its work, the harness triggers an event, which is a stop hook. And you can wire that up to a shell script that you run, for example. So you can automate running your test suite or your guardrails. I like to call them guardrails. And you need to engineer your guardrails so they actually output like natural language text. This is forbidden, do it in this and that way. So the feedback encodes the prompt that you would write as a human. So then you trigger that, and then that triggers the LLM to continue working on the thing. And you can pair, these feedbacks that you give with things like Ralph Loop, Codex and Claude, they now have the goal command, which really helps. So they will just keep running for longer and longer until they fix the issue.
Yeah. So Ralph loops specifically allow you to run whatever you want to do in a loop, right? So it goes over it, and this feedback mechanism would then be input in an iteration to get it right and to correct it. Goal is something similar?
The idea is the same.
The idea is the same.
Yeah. I don't know exactly what the implementation of Goal looks like, but it seems to be functionally equivalent to a Ralph loop.
And which of these guardrails that you've put in place gave you the most value? You mentioned linting already, some security controls. Do you have more examples?
So I didn't know before, but I've since become a great fan of semantic grep.
Okay. Yeah.
Because it allows you to put regexes for things that it could catch in code. For example, a certain type of code construct. The example that I always give is I don't want any default values in any of my methods in Python, for example. You can set default values for parameters in Python methods and in the signature of the method. And this, in my experience, is one of the greatest sources of frustration when you have to review and debug the code later. So I just prevent that by putting a rule that detects these code patterns, and that then triggers error. You must not write it in that way. It's against policy. So semantic grep is really flexible. And whenever I interrogate the AI about the code that it wrote, instead of reviewing the code myself, some of these issues come up. Why did you do it that way? It doesn't make any sense. That immediately triggers me, okay, let's add another guardrail rule for this particular type of pattern. So what then happens over time is you're shaping your environment, you're iterating towards it to be tighter and tighter to be aligned with your preferences as a human.